So now we can continue with the introductions of GitLab, just to make sure that everybody is actually on the same page before we get actually started. It also gives you a bit of more time to go through the rest that we have done already. So 15 plus years ago, this is essentially what a typical multimedia landscape was looked like, essentially. So we had an application for a phone, not an application, we had a phone essentially. We had a separate calendar, our email was somewhere, we were carrying a camera around. We might still be carrying a camera around today, but typically you needed to have a separate camera there. And everything was potentially slightly connected to each other. But you had to be lucky that Nikon and Walkman, in this case, don't think that ever existed, but that there was an integration in between. That entire business was disrupted by the invention of something new called a phone. Well, actually, not really that phone, but rather the smartphone, that one. And that was all tied in together into one single mobile platform where you have essentially the ability to, well, still take a phone call, but look at your calendar, send emails, take pictures, send those pictures easily by email, while listening to music even and surfing on the web. Everything can be done on a single device, which means it was a disruption of multiple industries by the invention of a single intuitive and integrated user experience, which is nowadays the default experience called the smartphone. So why we are here, we recognize this symbol, the same principle essentially. So we typically have multiple point solutions that are not really coupled to each other, where we have been using those because we were growing in our delivery landscape, in our software development lifecycle landscape, and because we were growing the landscape, we meant that we always had to add more and more capability. We had a need for more capabilities, which meant selecting the tool and adding the tool to our tool chain. Unfortunately, that means that that becomes a tool chain sprawl. Also because of multiple new technologies that are being added, new principles like microservices, means that there's more and more projects. And if you combine that with the tools that need to support those projects, you have essentially what is called a tool chain sprawl, and you end up with a DIY DevOps, because you realize that there's a lot of information in those tools, and you need to have a more and easy way to connect the dots. So it means we require custom support for orchestration and integration. All of that requires a lot of work. Make sure that it's hard for the organization to measure the transformation, because that information needs to be consolidated somehow. And it makes it hard to collaborate, because even a single thing as starting a discussion around an issue or ticket ID will require you to identify which application that you're talking about, potentially from which team that you're talking about, so in order to get the latest information. So visibility and collaboration is not that easy in that landscape. That's the reason why GitLab has pulled all of these capabilities into a single platform, because it makes it easier to bring these capabilities to in the same dev cycle, which means there's transparency, and everybody knows where to look at the latest data. Also means you have things like unified permissions. Makes it simple. You either have access or you don't. You're not leaking information accidentally between the tools, where giving access to certain types of information that somebody in the organization should not have access to. It also means it's a single interface, a single pane of glass. It also means no context switching. And so you're losing less time with those context switches, which creates consistency in governance, compliance, and security as well, because, well, you know where everything is. So GitLab can replace all of those tools or add capabilities on top of it and link in between. And gives more visibility as well. So because we have all of those different events in the same application, the same database, in the same data store even, we can more easily start measuring and building things like value streams as well. For today's workshop, we will focus on a couple of things because, well, we only have a couple of hours that we have to, so we have to focus on a couple of things, which means we will cover manage and planning of the work, how to do day-to-day creation, so development, and how to automate the CI/CD pipelines, which is the part that Nupur will be covering, and how to release it, of course. To bring it all a bit more into a context, we have a small story around that. So welcome to the team. You might not realize, but you just joined the new team in a new organization, and you're officially part of a brand new startup that is creating the public leaderboard for the hit new racing game, Tanuki Racing. Your company has recently swapped over to using GitLab for project management and has tasked you with learning about the different pipeline capabilities. So let's get started with it. First of all, we have to organize, track, and define our work. So your first task is to create a group on GitLab and some initial issues so the development team can get used to using GitLab as a single platform for all of their development needs. If you look at the map, or the map of all the stages, it's the manage and the plan stages that are involved here. So organizing work, essentially, we are using groups to provide capabilities, essentially to assemble related projects together, to put multiple resources together. Can either be on a group level and put all the repositories together. And it can also be used for access management. So you can have multiple members being added to a group, and then that group can be provided permission to another group. How you structure your groups, that's up to you. In general, the group itself is a layer for strategic planning. So all the information will be aggregated to the group level, coming from the lowest level, which is the project level in this case. So as an example, you could have the project, which is where the teams collaborate, plan work, write code, etc., which gives information back into the team level. And so there you have an overview of the different information that is coming from those projects as well. So that's organizing work, essentially making sure that all the work is structured. Next up, you have defining work. And here we're going to leverage epics and issues. So epics provide essentially large body of work, so strategic initiatives across the organization or that could cover multiple lines of businesses can be typically set into an epic. And we can have either sub-epic or issues attached to that. So in this example that you can see on the right, an epic can be a capability, and a sub-epic could be a feature, which is still a large body of work, but smaller than the capability that we're discussing earlier on. Then we have the issues, which is small, discrete pieces of work that are described in an issue. We call it a piece of work because it really depends on what you want to do, and you can leverage for multiple things. As you can see as the example here, you can have issues that are directly linked to the capability in this case, which might mean we define non-functional requirements over there, or acceptance testing, or whatever you want to do can be on that level. And on a sub-epic and the linking issues there might mean we're actually writing our user stories there. But in the essence itself, it is both an issue and both are epics as well. But you can, well, mimic in the structure that you want. Then we are going to plan work. So we're building out roadmaps, and roadmaps are automatically built out based on information coming from the groups and the epics. So an epic is always going to be created on a group level, because it's logical to have it on a group level. It is covering multiple things, typically in multiple projects, even multiple subgroups if needed, which means that an epic makes sense to have it on a group level, while an issue is always going to be on a project level. Now, the roadmap will display these epics that are within a group and the subgroups in a visual representation, like a Gantt chart, essentially, what the timing is for it. Next, you have iteration, and that we can use iteration to track issues over smaller periods of time, like for instance, sprint. And in between, somewhat, we have the milestones, which is on group level and subgroup level. So you can have multiple levels of milestones there as well, where you can track issues and merge requests against a certain period of time at, well, those different levels itself. If you put that together, then you end up with this. So organization-wise, we have groups, subgroups, and projects, which means we're supporting inheritance and coordination there. So the lower you go, the more details that you will get the information. The higher you go, the more broader your information will be. Then we're defining epics and on a group level, and issues which can roll up from subgroups and the different projects below it. Next, we have sub-epics to clarify it slightly more in what is meant in an epic, and then issues that are, well, actionable items that need to be picked up. In the meantime, within those issues, we also have tasks, but I don't think we will be covering that today. But it's just, well, another level there. And while doing that definition, because of that inheritance and the group structure, we can have traceability from the bottom up there as well. So at the bottom one, we see the project milestone. So milestones specifically created for and within that one particular project. And then we can view the roadmaps on all the group levels. So both on subgroup level and on the top level group, essentially, because information gets aggregated there as well. The group milestones and the iterations can be created on a group level, and then it will be available throughout all the subgroups and the projects over there, which means that if you create it on this level, all the projects can link to the same milestone as well. Then doing the work, well, because we actually have to do some work sometimes as well. The Git repository itself is the foundation of a GitLab project. So each project has a GitLab has a Git repository in GitLab. The Git repository itself, if it's too daunting and you want to have a planning focused project, that's possible. You can disable that, that's fine, but it will always exist there because it's the basis of your project. There you will find the merge requests, and the single sort of fruit of the different changes that we're doing. The CI/CD pipelines will be there, so essentially the runs and the results that come out of the newly created code will be there. Will also be visualized in the merge request itself. Code reviews are done there, so essentially making sure that everything is up to the standards of the organization. And finally, because you have all of the information readily available, you have the approvals there. And there you can also set up the right policies, the right rules on when an approval is required and when it can be an optional approval. Then we can label it all. And labels can be used in multiple ways. It's a way to, well, add metadata to your issues, to your epics, to your merge requests, which means that you can more easily filter and dynamically filter on a couple of things. It also helps you to search, but it also helps you to specify what kind of issue or epic that we're talking about. You already mentioned before that issues can be leveraged in multiple ways. Epics can be leveraged in multiple ways. Well, the way that you can segregate the meaning of between a bug or a user story or the capability in an epic, for instance, is by adding a label to it. But you can also use labels for essentially prioritizing, and that's what we see here. So as just dragging one type of label above the other means that all the issues, all the assets that are using that label and having a bug label there will have a higher priority, and in this case as the critical one, or vice versa, depending on how you have dragged it. Last but not least, here we also have the principle of scoped labels. And scope labels are essentially, well, mutually exclusive activities, which means within the same scope, in this case it's workflow is the scope, you cannot have multiple multiple values of the same scope. So meaning in this case we have workflow planning, workflow review. If I have planning that is already assigned and I apply review to that issue, for instance, then it will override the planning. So it will automatically remove the planning one and add the review. So that's perfect for workflows. And you can have multiple workflows for the same issue, but well, it's important that within the workflow, you don't have multiple steps applied at the same time. So if you have doing, to do, and done, well, to do, doing, and done as labels, it does not make sense to have all three of them assigned to an issue. You can do that with a regular issue, but a regular label, but you cannot do that with a scope label. All right, enough talking. Time for some exercises. So we will use these issues. Hopefully everybody is now set up for the lab itself. The issues were already highlighted by Logan. The URL. And I'll swap again to these two. There you go. Share. I accidentally opened it twice. So as a reminder, make sure that you are in your my test group with the unique name behind it. If not, go back to your GitLab.com, GitLabDemo.com environment, set the invitation code, and click on My Group, which should bring you back into the right group. Now, for the first lab, we're going to use the first issue. So it's issue number 1: organize, track, define, work. There you go. You can start working there. By the way, we also have a beta of a new navigation. Feel free to try that out. Know that the screens will change slightly, and the order of the menu will be changed slightly. So for today, I'll keep it this way, make it easier to find it back in the screenshots. But in the future, then it might all change a bit. All right, so we're going to start by creating a new subgroup. And the steps are there. So what we need to do is we'll click on the new subgroup button. Give it a name, for instance, the racing group. Okay. There you go. You will see that the visibility level is only available on private, and that's because our main group, the top level group here, is also set to private, which means that you cannot have anything else. Otherwise, you would have the option to make a public group as well. So I'll create a subgroup over here. And that was step 1. And step 2 would be creating a project. So we do that by clicking the new project button over here, the top right, the blue button. And then we're going to start from a blank project. Now my window is a bit small over here, hence that it comes all below each other. If you're of a bigger screen, it will show like this, but it's actually exactly the same thing, just because of the screen real estate. All right, so create blank project. Give it the name, like leader board project. There you go. The name itself does not really matter. Just make sure that you remember which one that you chose. And then by clicking, so keep everything selected, private, and the initialize repository with README, because we will need that before. So if you click on create project, the project will be created. All right, I see that there's a question to repeat the first step again. So you mean the subgroup one? So that's here in the My Test Group. So make sure that you are in your own test group that was created. If you're not sure, click on the blue button in gitlab.com. And then here, next to the blue button on the top right, you see new subgroup. So click there. You can just give it a name. You will see that whenever you're typing, for instance, Logan is here, whatever, the slug will be updated automatically. And as long as you don't have special characters there, so if you do an asterisk here or something, then it will still work. But you do it asterisk there, then you might have some issues. Well, actually, I don't know whether asterisk is a problem. Anyway, it's advised not to have special characters. And if you click on create subgroup, then that subgroup is created, and that's where we were for step 2. I won't create a new subgroup because we have one already. And then the next step essentially was to create a new project. And we've done that by, well, actually we were in our group already. Make sure that this is essentially showing your newly created group name. And then by clicking on new project, you will get an option to select from a blank project, templates and more, but we are selecting the blank project now. Similar to the group, fill in the name, the project slug will update automatically. Keep everything as is, and just make sure that initialize repository with a README has been selected, and that creates the project, and then it should be on the same level as we are. There's always the link for the docs. So whenever you have, well, whatever you need to read more, you can click on that link after the workshop and start reading it. So now we are going to create a couple of labels. This can be done either on a project level, and this is on a project level, but know that you can also do that on group levels, which means that those labels will then become available to everybody in the subgroup. All right, but in this case, we're going to do it in the project level. If we select our project, and the left side, And if I open it up, it says project information. And there we have a sub menu item that's called labels. There we're going to create a new label. And we will be creating 4 of them. Just enter the labels. So we need to create P1, P2, and then 2 scope labels, workflow planning, workflow review. So I'm starting with P1, and P1 means red for me. So you can select your color. The description can be filled in. I'm not doing it now, but the description will be shown whenever you hover over a label, then you have that description. So if you want to clarify some bit more, it's a good practice to actually fill it in. But for now, it doesn't really matter. So just select the color, click on create label, and the label should appear there. And this is something that we're going to do a couple of times. So P2, red, create label. Click on the blue new label button again. And in order to create a scoped label, we need to use the semicolons. Yeah. So workflow. Well, 2 times a semicolon essentially, and then whatever you plan to use right after it, it's like the value of that that label, that scope label. So before it is the scope itself, and behind it is like the value. So you can think of it as like a drop-down box. Drop-down box is saying country, and within the drop-down box, there's only one value that you can add there with a simple drop-down box at least. And that's actually what we're doing here. So adding the scope and giving the value. I'll keep it at blue, create label. And then last but not least, workflow. And then review. And create label. There you go. And so you should end up with 4 different labels. Are we okay? I guess silence is good in this case. Yeah. So next step is to create a board, an issue board. In order to do that, we can go to issues and their boards. By default, you will have a development board, which is pretty empty because you only have open and closed. But what we're going to do is create another board. And in order to do that, we click on the drop-down of where you currently see development, and then click on new board, create new board. Every new thing needs a name. So the scoped board is the example that was provided. You keep it just everything selected as is, and then create the board. There you go. We now have a new empty board. And so in order to make this work, let me minimize these 2. You don't have to do that, but it's just to save some screen real estate. I can create a list, and these can be multiple things. For today, because we just created a label, we're going to reuse those labels. For instance, what we're going to do is add the label planning to the board, and you see that there's a new pane coming up. And then we're going to repeat the same thing, create list, select label, and then as value, select the other value, which is review, and add it to the board. And now, oh, sorry, that was not the goal. There you go. And now we essentially have created a new board with the workflow planning and the workflow review stages, labels in it. Next, and you'll notice that this is a lot of setting up to do in the very beginning. The advantage is once it's set up, it stays this way. So you can just continue and concentrate on the work, the actual work that you want to do. So we're going to create a new milestone, which is going to the issues menu item, and then you have milestones. Click on the new milestone. And here we're going to have a nice title, GitLab migration milestone. And as a start date, just take today, and the due date is 1 week from now, which is the 4th, I guess. Yeah, there you go. Typically, you can, as part of the milestone, you can specify what we're going to do. If you have PI planning, for instance, for this milestone, you can say, well, these are our goals for this milestone. These are our stretch goal. Everything that you want, you can put it here because it's a full markdown editor that we can leverage there. Create a milestone. And that's it for step 5. You see, whenever you create a milestone, it opens up the milestone page itself. You see things like burn down and burn up charts, everything that will be available as from the issues will be fed into this, but we'll revisit this briefly later. Next, we are going to create some issues. Now, there's multiple ways of creating issues. In this case, we're going to go to the we're going to go to the issues page because we are already in a project. Sorry, I have to follow myself. Here, issues. And then we can create a new issue. That's one way of doing it. At the top, you have the plus sign. There you can also say new issue in this project. You can even type in letter I on your keyboard and it will open up an issue. So multiple routes to the same thing. The goal is that you create a new issue in the project that we just created earlier on. In this case, we're just going to do a modify a README. And yeah, the goal of the issue is the problem statement. So you're going to specify what you want to do. For now, this is self-explanatory. I can assign it to me. And then you will see that your assignee will be filled in automatically. We can link it to the milestone that we just created. So the GitLab migration milestone in my case, by just clicking on the drop-down menu and selecting the right milestone. And we can add a label to it, like P2 in this case. A weight, which will depend on what kind of framework that you're using. In this case, you can just specify it as a 2, for instance, and a potential due date of next week. Or somewhere next week, let's take the 2nd. And by creating issue, by clicking the create issue button, the issue will be created. And we will see that everything has been applied. If I go to my right sidebar, it might be expanded already for you. You see that the labels are being applied, the milestone is there, the weight is there, the due date, everything has been filled in based on the information that we just provided. Another way of doing it is by using quick actions. So let's do it again. I'll do this route this time. New issue. We have a new issue, and we have a new title at SAST scanner. And one thing that we also support are description templates. And so, in order for not everybody has to keep on typing the same thing, and as more as a value, making sure that everybody uses the same format as part of your issue. you can leverage description templates. So if you click on choose a template here in the description box and select the workshop template, you will see that it has the content and the description of the issue will be filled in automatically. Now, this is a markdown essentially, and just some text. But at the bottom here, you see what's called quick actions. And quick actions means something that you can apply to your issue in this case by typing text. Some of them will work already. And if you click on preview, you see what these will be doing. So it's adding P2 label, it sets the weights, and it sets the due date. However, it says we have a problem with the assign command, file to find users. Let us check here, and that's correct, because we did not specify a user. So what you can do here is say @persons, which is my username. And you see here that I've got multiple groups that's starting with the same thing. I can also assign an entire group of people. Remember from the very beginning, groups can be used to have multiple repositories and projects that are being grouped together, but you can also use it for members. And so here I can easily say assign it to me or assign it to an entire group of people, and essentially that makes it easier, because otherwise you need to specify it one by one. The milestone itself, I chose another milestone name, which means that I have to select it here. And the entire editor will react on a couple of triggers, like for instance, whenever you do a percentage, it knows that it's going to be a milestone. Whenever you do a hashtag, it knows that we're going to link it to an issue. So like this, it's easier to start using it. Now we can use our preview again, and now we see that everything will be filled in or recognized correctly. And if I now just create issue, so I did not specify anything else in the form, only these quick actions, I can click on the create issue button, and you see that the end result is exactly the same as before. Everything is filled in, the labels are filled in, milestones are there, everything is there. The only difference is we have done everything as part of the quick actions, as part of the description of the issue itself. All right. Now that we have two issues, we can progress those issues in the board itself. Once that has been created, you can go to issues and boards. Make sure that we select our newly created board, so the board that we created before, by clicking on the development dropdown and then team scoped board. And now I can open it up again. And here we can see our two issues that we just create that appear here. And so what are we going to do? We're going to drag the add SAST scanner into the workflow planning list. So here I just drag it there, which means that it now shows it as being part of that list, but it also means that it has been added while you don't see it here, and that's because it's part of this workflow planning panel. If you click on it, you do see in the labels that workflow planning was being assigned here. Right, and so now this one, if we select it and drag and drop it to the review stage, you see that the other one was automatically removed. That actually happens for all the lists, but because it's a scoped label, it is also going to be the case differently. So you can actually see that by adding the planning, we have an audit line that was added here, but by adding the review scope label, the planning label was automatically removed. All right. Yeah, back to planning. All right, and now because we have done a couple of actions, we can actually review our project milestone charts, which means if we go to issues and milestones, you see that now in our overview of all our milestones, we have the newly created milestone that has 2 issues in it. If I open it up, we'll see that we have, well, the burn down chart, which is not really burning down yet because we just added it. But it gives us an overview of the issues that are unstarted, the ongoing issues, which is essentially what we are working on, and the completed issues for this particular milestone. That's it for the first workshop. As usual, as a reminder, any questions can go to the Q&A section. Also, if you're stuck with something, feel free to reach out, and we make sure that that you get helped along the way. In the meantime, if there's no questions, I'll continue with the plan portfolio releases. So now that you have some issues added, we will want to fit them around into some epics. And so let's make sure to create the epics around. Wait, let's make sure to create out epics around getting the team familiar with the GitLab product and learning the security CI/CD capabilities. So what are we going to do? You have parent epics and you have child epics. On both levels, you can add issues to it. And at the highest level, an epic is a large feature or large body of work that involves multiple discussions and different issues and different portions, essentially, which can on its own still have sub-epics, which are called child epics here as well, or issues directly. You can have up to 7 nested child epics. The epics then wrap into a higher level roadmap that tells you the complete story of the development. Where are we at the moment? How far along are we? What are we still planning to do? And where will we end up with all the development itself? That means that we can go to issue number 2 and continue with the our work that we have done before. And it helps if my screens don't continue to swap all of the time. Anywho, there you go. So back to the lists. You can use you can always use the breadcrumbs for that. And so to go one step back, essentially, to issues. And now we can go into the plan portfolio releases. These tasks are going to be completed in the Tanuki Racing Group, which is actually the group that we have created. So if you chose another name, that's essentially our group that is sitting where our project is part of. If you're like me in the milestone or anywhere else in the project itself, you see at the breadcrumbs essentially that you're going to go to the group, the milestones in my case here, then the project, and then the group. So if you click on the group, that's where we want to be. Because there, if I open it up, you will see a menu called epics. And so we're going to go here, epics, a list in this case. And similar to what we have done to issues, we are going to create a new epic by clicking on the blue new epic button. Title first, GitLab epic. Similar as before, can add labels to it, just add the start date here today and the due date for next week, and create the epic. There you go. Our first epic was created. The sidebar has been updated as well. So we selected the fixed start and end date in this case. You can also specify the inherited, which means that it will base the start and end date based on whatever child issues and epics are linked to. So it will do a calculation of the earliest starting date and the latest end date of everything that we are linking here together, which gives you like a dynamic view of what's going on. Apologies. All right, so now we can create sub-epics, can be done in multiple ways as usual. In this example, we're going to click on Add in the Child Issues and Epics section. I'll close that one. So here you have the Child Issues and Epics. We can click Add here. And as we have shown before, we can add issues directly here, which means that there will be a direct relationship between the epic and the issue. In this case, we're going to create a sub-epic or child epic, which means we're going to add a new epic here. It'll ask us for the title, test security epic, and we can leave the group as it is and create the epics like this. And now we have a relationship. And so we have created a new epic essentially and build out the relationship, the parent-child relationship between our first GitLab epic and the test security epic itself. Do that again. Same, click on the add button, click on add a new epic. And there we're going to do the same for the test CI/CD epic. There you go. And now we have multiple of them. Next, we can assign issues to each of one of these sub-epics. So I can click into the security epic. There you go. So we're zooming in essentially on the security epic there. We can still see the relationship. If you go and look in the sidebar, you see here the ancestors, and it will show you all the ancestors if you're in a deeper on a deeper level. Same here. We're going to go to the child issues and epics, but this time, since we already created the issue, we're going to add an existing issue here. So I can click add issue, add an existing issue. And from the moment that you will type the hashtag over here, you get some options. It's a security epic, so I'll click on add SAST scanner. Well, if I actually click on it, there you go. And by clicking add, you will see that it's now linked as well. All right. If I go to Tanuku Racing Group, for my group level itself, I can go to my epics roadmap. And there you will see the visual representation of what we have done at the moment. So we have our top level epic, but we can open it up to show the sub-level epics that are here. This one, we didn't specify a start and end date, which means it is just ongoing all of the time. If we specify the start and end date, or if we add issues to it, which on its own have start and end dates or are linked to a milestone with start and end dates, then this view would get updated automatically as well. And that's the end of the second exercise. How are we doing? Everybody able to follow along? I will turn it around. If you don't follow, if you're not following, or you're unable to follow, raise your hand and we will make sure to reach out. If not, I'll continue by doing a break. So that gives you some time essentially to, well, to finish those exercises as well. Let's say 10-minute break until, well, in 10 minutes. For me, it's 3:08. Let's say to 3:18 then. Is that okay with everybody? I'll try to come up with a timer. Feel free to get something to drink, refreshments, some fruit potentially. Going for the last seconds. All right, hope everybody is back in the meantime. And to check that, we have a small poll that we're going to do. Very complicated question. You want to launch it, someone? Oh, how are we doing in speed? It's too fast, too slow, outright. You need help? Not sure where you are. Fortunately, I can't answer because otherwise I know what I would answer. All right, thanks. So most of you answered. Yeah. Oh, yeah. There you go, sharing the results. So for most of you, it's just right. Too slow, apologies for that. I'm trying to cater for everybody. And whoever answered that it's too fast, feel free to reach out. We're happy to provide some assistance where we can, essentially. I also have some good news for you, which is it's my last section, and it was my last section, and so I can hand it over to Nupur whenever she is ready for it.
Yeah.
You want me to start a countdown timer as well, Nupur, to see how fast you can do it?
We'll see. If you can just unshare, then I can share and see if everything is working properly.
Yeah, very, very good point. There you go.
Can you hear me clearly?
I can, yeah.
Okay. Let me quickly put the windows in place. So give me a moment. Yes, that should be good. Okay. Let me share my screen here. Did you unshare? Because it's still asking me to stop sharing and then try again.
Yeah, I'm not sharing anything.
Okay. Give me a moment.
Yeah.
Can you see the same screen where you paused?
Yeah, I see. Are we getting another break?
Do you want one?
No, no, it's fine.
Okay. I hope everyone is back again and we can start. So, till now, Christoph gave us a very good overview about how to do planning, how to make epics, issues. But once they are made, it's developers' time to get started and work with the issues and resolve them or create a new feature. So we will be following the same format Christoph followed. We'll be going through some slides now. And once they are done, we'll be going through the lab. If I'm too fast, please let me know. I'll slow down. And let's get started. So we set up the lab. We already saw introduction to GitLab. We organized, we defined some work. We also planned our portfolio release. Now it's the developer's flow time. So What we are going to do for this particular session is to modify the README tasks. So if you remember when we created the project, we said we have to initialize with the README, right? So we will be changing that and see how our developers are doing at the back end to the existing merge request and issues, right? If somebody is not a developer, it's okay. We are just going to see how once the portfolio management is done, issues are created, epics are created, what happens at the back end, how developers do things. And if you want to understand yourself where the developers are currently in the development cycle, there are quite a lot of information already there because we're using the same platform. You can deduce it yourself. So with this particular area, we will try to understand what all information is there and how you can understand what's going on in the developer world. So in the whole complete DevOps platform, this is the chain. And when we talk about developer workflow, or what we will be going through now is this stage, create and verify. So we will see the results of the merge request, and then we'll create and merge it back into the master. So this is how the GitLab flow works. So GitLab flow is based on creating a branch to develop on, a place where we can develop and collaborate. When we say a new branch, usually there is a master, right? It can be a production or a pre-production. This master, if you try to change every now and then, it can be ambiguous and you do not know exactly what's going on, right? Instead of that, for every changes we are trying to create, if we create a new branch, it's easy to track what exactly are we changing. And if something goes wrong, if the developer adds a bug, or if the development, what is expected is not what we see as part of the developer change, we do not have to revert everything and make everything right again. It's a separate branch. People can just check it over here, fix it, recommit it, make the changes again and again till everything is good. Then you can have the reviewers review it. And then once everything is done, everybody is happy with the changes, then only merge it into the master. This protects the main branch from making the changes that could break again and again. Also, you have the ability to protect branches from the unauthorized changes. What does that mean? Suppose you have a new intern coming in your organization and they do not know about things and they thought it's a good idea, let's deploy something into the production. But those changes are not meant for production, or those changes are not reviewed by a senior person. So to avoid those kind of changes, we make sure that anybody who wants to develop can create a new branch for themselves. They can push the changes on that particular branch. They can build it, test it. So all kind of tests, all kind of scans, vulnerability scans, we will see it in the upcoming lab. We can do it here. We can automate build and test. Once everything is there, you can make it review. The senior personnel, SMEs can review the changes. Once everything is good, they can approve it. Approvals are not mandatory depending upon team to team, organization to organization. You can have approvals in place, or you can choose not to have them. And then once everything looks good, it can be merged into the master. So let's look at how a GitLab merge request look like. So if you see, there is quite a lot of thing going on this merge request. For example, in the first part, there is concurrent development details, right? So you can see over here, you have commits. So if you want to understand for this particular merge request, how many pipelines were created, what are the change differences? If I want to understand what's the code difference, which the developer made, all these kind of things can be seen from here. Also, in developers world, they want to create branches. Just explain what the branches are. So if you want to see what branch is related to that merge request, where it will be merged, all these kind of details are also provided over here. Then at the second area, we have pipeline test, build test. So here, if you can see, it says pipeline, right? So any kind of pipelines which your developers will be running, we will also learn pipelines in a moment. You can see the details over here. You can see if it's passed, if it's failed, if it's already running. So it gives an idea about if there is currently something going on within this merge request. Then you have a review app. Review app makes sure that in case this is the review app. If you're using Kubernetes, or if you can create a environment on the go, you can create review apps which will make sure the changes which you have made to the branch can be seen over here and can be reviewed by the product owner, by the product developers, and can be verified and say if they are satisfied with the changes or not. Then we have an approval process from the security. This can be security, this can be any SME, any senior who wants to look into the code changes and say if he's happy with it or not. So these kind of approvals can be in place, and once everyone is happy, everything is fine, they look at the changes and they say, okay, we are satisfied with that, they can approve it, and then only a person will be able to merge. Then there is app security scans. This is one of the most interesting areas for developers, because sometimes, I mean, when you're running your scans and you have a huge dashboard to see, you do not relate to what exactly did you do to break things, right? So over here, it clearly states on what kind of vulnerabilities the code changes you created had, right? So you can look on the vulnerabilities, go one by one, understand them, and maybe try to fix them before pushing it to the master. So this gives a very nice area for the developer to see what kind of security vulnerabilities were introduced as part of the code change, rather than after production or after pre-production trying to understand what did the developer did to break the vulnerability, or to break the security, or what kind of vulnerabilities were introduced. So where do I start? So we are talking about merge requests, we're talking about pipelines, but I was on the issue board. Christoph just landed us on the issue boards. So where all these kind of things come? So it always starts with the issue board, right? So as a developer, I just want to understand what's there for me, right? Which issues I need to work on. Christoph also showed you how you can create multiple boards, right? So we created one board. In that way, you can create multiple boards. For example, you can create a board to say, okay, these are the work. So these are the work which requires backend expertise. This is the work which required front-end expertise. This is the work which required UX expertise. So different members of your team can check these works and say, okay, I can maybe pick up this one because I'm a backend expert. I'm a UX expert. I can pick this one, and so on. Another way of creating a board can be, you can create boards based upon your sprints. So you will have all the definitions, all the issues which are part of the sprint, and the team can take it from there. So again, it depends upon team to team, organization to organization, how do they want to work on. But a developer always start looking at a board, and then from there, the journey starts. So when you have an issue open, there is something called create merge request. So for every issue, there is a button where you can create a merge request. And this is the place where the developer journey starts, where the development actually starts. So once you start creating a merge request, a draft version of a merge request is created. What will you see in that draft version? You will have a draft title. Usually the draft title also resembles the issue. So that gives you a context about what this merge request is trying to resolve, right? It will list the branch it's tied to. So whatever you are working on, it will create a branch for it, and that branch will be listed over here. It will prompt you to identify and document the changes and impact those changes on the branches. So it will tell you just put something on the whatever you have to tell what impact will it have on the branch. Also, there is a small button here, say web IDE or checkout locally, right? So for the developers, they are not that much interested in the browser one, right? They are always into their command lines and trying to push code or create changes from there. But for those who are not that tech savvy and still wants to contribute in documentation, in pages, they need not go through the whole extensive process of command line and learning all those kind of things. You can just go via Open Web IDE. It will open it will open the code in the browser, and from there you can make the changes and push your code. So today in the lab, we will be using Open Web IDE part to make the changes. Okay, so if you see, this is kind of a built-in IDE which we have for the code changes. So once you open that IDE, you will be provided with all the details of the codes. You can make the changes over here and just push it from here. Now, as the merge request goes through the pipeline, you will see the history of activities, approvals, quality scanning, and everything. So as you develop more, as a developer commits more, as the pipeline run more the details of the pipeline activities are provided here. So the latest pipeline which ran for this particular merge request will be shown over here. You can see if the pipeline failed, if it ran successfully. You can also see the approval processes over here. So based upon your approval list, you will see who needs to approve it. You can also see the results from here. If you want to check if the code quality is decreased or not, if you want to check if there are any vulnerabilities, if you want to check if the license compliance is being followed or not, you need not go on different dashboards or different areas. You can get all kinds of details from here. This also gives an idea how far a developer is in his development processes. If you see a lot of security scans, you already know that it might take some time for him to fix it, and so on. So another point on the merge request is the changes, right? So we said here we can get quite a lot of details, overview, commits, pipelines, and changes. This is also very interesting area because you can understand what exactly changed, right? So what are the code changes which were made? You can start an asynchronous process with your colleagues where you can ask question, you can start a review. This makes sure that instead of going to the team or asking someone to come and review your code, you can do an asynchronous communication around your code changes. On the other hand, everything can be reviewed. You can always have reviews. You can always ask someone to check if everything is good or not. And once everything is done, you know exactly it's finished, the review is finished, we can go ahead. So instead of bothering or asking for meetings or asking for times individually, you can just start using a collaboration tool, right? That's the fun part for the collaboration tool. You do not have to knock doors on other colleagues of yours. Here, if you see, it says 0 of 1 thread resolve. So once you start discussion on, I don't think this is good, or why did you make those kind of changes, you can here say if everything is resolved or not, or we are still discussing. This also gives an idea to the approvers. It can be product owners, it can be security personnel, it can be SMEs, if they need to wait for everything to get resolved, or they can give the approvals, right? So if you already see there are unresolved threads, if there is a long discussion going on the code changes a developer has made, it's not the right time. And maybe you can also, if you are an SME, you can provide your inputs. If there is something related to the requirements, a product owner can clarify them, and so on. So it gives you an idea if everything is going right with the changes or there is a huge discussion over it. So GitLab merge request reviewers allow authors to request a review as well as see the status of the review, right? So depending upon what kind of review is needed, in the merge request, a person can just ask someone to review the changes, right? Or be a reviewer. It's pretty simple. You can just assign a reviewer on the, so if you go on the right hand sidebar, we'll see it in our lab. You will be asked, you can put the name or the user ID of that particular person, and you can just assign the reviewer to a particular person. Once you assign it, the reviewer will get a notification of the request that he has to review the merge request so that he can go on that particular merge request. It makes life easier for the reviewers as well, so that they don't have to go on each and every merge request to say, okay, this is something I have to request or not. So they can just go on their task or on their emails and understand what needs to be reviewed, right? Also, this makes sure that there is a formal requesting, right? So it's not like, okay, I asked my colleague to review it and everything fine. There is a formal process behind it where you request somebody from your colleagues to review it, somebody from your peer reviews it, and once it is done, he can formally say, yeah, I'm happy with the changes, and then they can go ahead with that. There is also something called suggested reviewers. So we have GitLab machine learning powered feature that allows a person to generate suggestions. So depending upon project's contribution graph, who is contributing to the project more, less, it creates suggestion for you. It generates up to 5 suggestions for the reviewers. And then based upon that, you can choose one of the reviewer. You can always choose your own if you do not want to, but this is great where where people are new to the organization or there's a long list of persons, and if you are using GitLab more and more, the ML understand the context change or commits to the MR, and he's able to the GitLab is able to provide you with better suggestions where you don't have to write or find a user, but you get an auto-populated suggestion for yourself. Okay, now we created a MR. Next, what? So this is the pipeline dashboard, which shows you the status of the pipeline. Now, at the back end, once the MR is created, developer starts developing. They'll make code changes, and according to our way of working, we try to make sure we can commit our code changes. So small code changes you can commit again and again. You do not have to wait till the whole huge change. This also makes sure if you break something, you know it immediately instead of writing 10 pages of code and then realizing, oh my God, I did something wrong, right? On the back end, these code changes, when you commit, the pipeline starts, and then these pipeline make some changes, and you can understand, you build it, you run tests on it to understand if everything is fine or not. To see the status of your pipeline, there is a CI/CD pipeline dashboard where you can see, okay, what pipelines are running, if something is passed or not, if something failed. If something is failed, you can just go on that particular area. You can click on that particular step. So if you see here, this particular pipeline, one of the step failed, you can click on the step, and then you will be able to see the logs, why it failed and everything. So this just helps you to see the historical pipelines, what failed, what not, and when something breaks, you exactly know why it breaks. This is a result or a closed MR looks like. So once everything is fine, you are happy with it, we get up all the approvals, you can just merge it into the master. If everything is right with your build, and everything gets merged into the master without any issue, the issue is resolved and it just automatically flows on the issue boards. So as we said, every merge request is tied to the issue, right? So this particular merge request was tied to 32, and once this particular merge request closed, this issue also closes. So you need not go and do it manually. Once a developer knows I have closed the merge request, everything is fine, the issue gets closed, and then he can start working on another issue. So now we will be hopping on the workshop. We will be going through the developers flow. So let's see what we have in this particular one. So this is again the steps we have to follow. I'll just go and click developers flow. So this is the flow which we have to follow for this particular lab. If you are somewhere else using the breadcrumbs, please come back to Taniki Racing Group. Here you should be able to see leadership project, right? I'll give a couple of minutes so that everyone can just come to this particular step. Okay. So if you're already into the Taniki Racing Group, you can click on the leadership project and we'll come on the project. All the issues, as already mentioned by Christoph, are created in projects, and epics, sub-epics are created in the group. Also, the code resides in the project. So that's why we are coming in the projects. We create merge request in the projects because, again, the code is in the project. So we need to be in the project to make the code changes. So let's get started with the lab 3. So first of all, we have to come back to the project. Hope everyone is back in the project. Again, using the breadcrumbs above, you can come to Taniki Racing Group, or you can directly land on the leadership board project as well. Once you are here on the left hand side, I'll go and I'll try to find my issues and click into issues. Right here, I can see 2 issues. I'll open the issue modify readme. So here I can see modify readme. Let me try to adjust my screen so that everything is visible. It should be visible, right? Now, this is the issue. So when you start with the issue, you have all the details over here related to epics, labels, and everything. But for the developer workflow, we have to go and create a merge request because all data related to the commits, the code changes, everything happens in merge request. So let's go and click on merge request. So once you see, again, this is the draft version of the merge request, and here in the description you see closes 1. So for the merge request which you create for a particular issue, it also automatically gets associated with that issue, right? So I'll go. We have created a new branch for it. So here, if you see, there is a new branch created, and it also says when this issue will be resolved, which branch it will be merged on, right? You can change it from here. I do not want to change it. I like the default format. It helps me to identify which branch is for which. So for example, here it says 1 modify readme. That means whenever I'm trying to backtrack and see why this particular branch is created, I already know this was created for issue 1, which titles modify readme, right? So I'll go to the down. Also, something worth reviewing is the milestones, because we had a label attached to the issue, because we had a milestones attached to the issue. These all things get automatically populated over here. Now I'll just go and create a merge request. and my first merge request is created. Here for now, because there is no code change activity, I'm not able to see any code changes, commits, or over here, but the history tracking is already started. So if you see here, it says I created a milestone. I added a P2 label. So when you are in a merge request, or as soon as you starts a merge request, all the activities done for that merge request are already loaded over here. So if you want to understand historically who made the changes, why those changes were made, you can always go over here and check for the history. Now, create merge request from issue is completed. Now we'll go on the second step, modify readme.md file. So for that, first we'll have to create on code. And again, we can choose checkout branch, open in web IDE. A few minutes back, we discussed this. Usually the developers love their command line prompts, so they check out the branch and do it from there. But maybe not so tech savvy. I do not want to open command prompts. I want to do it from my browser. So for that, I can always go and use the web IDE of GitLab. Let's click on it and see how it looks like. So here you see, this is the web IDE, and this is the file we need to make the changes. Click on readme.md, right? Once you click on it, the readme.md file is populated over here, right? Now it says, click on the source control. So we and add a new line to the file, right? So let me make a comment over here. Add a new comment for readme. You can put anything you like. Once it is there, you can just go here. You can see source control, one pending changes. It tells you more about, okay, there is one change which needs to be merged, right? So I'll click on it and it says commit message. I'll just put a commit message. Again, this is a nice way of tracking what exactly and who did or why the change was made. So as a developer, you are always advised, whenever you make a change and you commit it, you put your commit messages. Developers are used to do it via command lines, but we can do it via here as well. So change readme file. For if you want, right? And I'll click on commit and push. So it asks, do you want to commit new to the new branch or you want to use the current branch? I do not want to commit to a new branch. I want to use the current branch. This is again something very flexible for the developers. If they are making changes and they think it is not related to this particular branch, they can from here make the changes and create a new branch. But because I exactly know my changes are there for this particular branch, I'll just use it here. And here, if you see, success, your change has been committed, go to the MR, right? So if I click on it, I came back again on my MR, right? Now, if you came over here, it's good. If you go to the, there was also an option to go to the project. You could have gone to the project. If you have gone to the project, you can from here, again, click on merge request and you will be navigated to this particular one. So depending upon if you took the step which I take, go to the MR, you will be directly navigated to the MR. But if you choose to go to the project, you can just from the left-hand side, choose MR and then land it on the modified README MR. Now we have created an MR, we have made a commit. Now let's prepare it for the review. So for that, we already are on the merge request. Now click on commits. Let's click on commit to see what happened. Now it will tell us what exactly, how many commits, how many times the changes have been made. Because I made only one time, it shows one, and it also shows the comments for me to understand why what exactly has been changed in this particular commit. Now let's go on the changes and try to see what exactly changed. So if you see here, I added a line, right? So here there you can see the difference. And if you are not satisfied with it, if you are not happy with it, you can always try to, start a thread over it and discuss your changes over here. I'm happy with it. So I'll just go and click on the overview part. And here I'll make my merge request as ready. So now it is in draft status. I'm happy with the changes. I checked everything. Commit said looks fine. So I'll put mark as ready. So my code changes are done. I'm happy with it. Now I can assign this to a reviewer, right? To make sure a person can review it and tell me if everything is fine from his side. So I'll go here. I'll click it here. And you can check any reviewers you want. So for now, I'll just assign it to myself. And this is how you assign a reviewer. So once a developer is done, he will mark this merge request as ready, so others can understand if it's ready or not. This also can help again business developers, product owners to understand where the merge request is, where the issue is currently in the development cycle, if it's currently worked on, if it's done by the developer and it's pending for the review, and so on. So once this is done, let's now, because I'm a reviewer, I'll try to add some comments to say, okay, I have done my reviews, right? So I'll say approved, changes, review complete, right? Now, here we have not manually given any approvals. Here, if you see, approval is optional, but in case of, if your use case requires some approvals, you can have approvals over here. So once the approver is done, instead of commenting, he or she can actually approve it via here as well. For this lab, we do not have any approval in option. I'll just put a comment that I'm happy, I have approved it, and I'll just merge, right? So now we need to verify. So we made the changes. Now we have to see if we can see those changes or not. So let's go on our project. So on the left-hand side, if you see, there is something called repository. Go click on the files. Again, on the left-hand side, we have something called repository. On the repository, first option is files. Click on that, and you will be navigated to the repository. Here, if you see, this is the README file, and you can already see the comment from me. So this is how a developer can actually make the changes in the code using a merge request. And once it is merged into the master, you can see the changes in the code, right? In the whole process, we saw how we can track the changes, how we can see if, how many commits, how many changes were made, what exactly code difference the developer did, and all kind of details. So I hope everything is already done for you all, or if somebody is lagging, I'll give a couple of minutes to complete. There is one thing which we can also see. So let's try to go, if you go on the board here. So I'll just go on the team scoped board, which we created. And if you see the README instructions, it is closed, right? So what we saw is, as soon as a developer says he is completed with the changes, he can be reviewed. If the review goes complete, his changes can be merged into the master. Once the merge is complete, the issue gets automatically closed. and everyone who's looking onto the board to understand what's currently going on in a team, they can see what all things are already closed. So yeah, this was all for this particular lab. Uh, Again, we'll wait for 2-3 minutes to make sure you have enough time to complete, and then we can go on with the next one. If you're having any troubles, please put your questions in Q&A. If I was really fast and you missed some steps, you can ask them in the Q&A. Okay, I hope everyone already done with the steps. If somebody is still trying to figure it out, can you put a message so that I know I still have to wait? Okay, so before moving on to the next, let's have the poll again to see if the speed is okay or not. Okay, I think it's complete and everyone thinks it's just right. A couple of minutes to see if somebody thinks I'm too fast, too slow. Okay. I'll end the poll and we can. So just right. That's good to know. Let's hop on back and start with the next phase. So it says break time. So we will be having a break of 5 minutes. It's 4 for me, so we will connect again at 4:05. So, hello everyone, we are back. I'll wait for a minute or two. So if somebody's bringing their coffees, they can do so, and then we will get started. Okay, I hope everyone is back again. And we will start with pipeline automation. I know it can be daunting to the people who are not developers, but I'll try to keep it slow and just we'll try to go through the lab and try to understand how pipeline works, how they look like, and if somebody who is not technical wants to understand some details from it, details you can get out of it. So let's get started. So we are here in our whole journey. We just finished our developers flow and we will be going through the pipeline automation. This is the final lab. So this will be our last segment. Here we will familiarize ourselves with the CI/CD capabilities of GitLab and how even non-developers, product managers, business developers can help contribute, how they can understand what's going on at the background where developer is busy making the changes. We will use some built-in templates to write simple pipelines. So I promise I'll not make you write lines of YAML code. It will be a simple template which we can just copy paste. And then the developer team, if they want to, they can come on and improvise it on later. But we will just use a small template for this particular session. So where are we on this particular journey? So we did manage, we did plan, we did create, verify before. Now in this step, we are somewhere in verify and release. That means we'll verify the changes, what we have made, and we'll try to release it in the upper environments. So basically, this is life of a developer like back in the development days. Like this was me when I used to develop, where I used to write code, and after writing code, it took some weeks to put it in the production. So 4 weeks, 6 weeks. And once it is in production or in pre-production, even in pre-production, somebody came to me and says, it doesn't work. It's broken, or you created a huge vulnerability in our system. I had no clue about what they were talking about because, yeah, 6 weeks back, I don't know what I was working on. I know what I'm currently working on, but yeah, I have no clue what they work on. To sit, to backtrack what I did, why I did, what were the changes. Maybe I did it with somebody else or I reviewed it with somebody else. It was really too much of task to go and work on that. This can be really hard for the developers if still, it's a week, like 6 weeks, even a week, it's too much of work, too much of changes for them. So if we can make this quite closer to when they are developing, so when they are making the changes, if we can get this kind of data where if I broke something, if I introduce a vulnerability, if I did something wrong, if I can had that context at the very moment, it can save a huge time for the developers, for the people who are checking on the production, pre-production, or who are deploying there, and maybe people who are impacted by it. So my changes can impact 10 different teams, 10 different other developers. So this can save huge amount of time, huge amount of energy for the people who are associated with it. And also for me, the context is still there. I know exactly what I need to make change if something goes wrong. So when we say shift left and automate, let's see how GitLab makes it easy to shift left and find and fix security issues early in the development, right? So with GitLab, developer works on isolated feature branch, we just saw. So any changes they are making, you know exactly these are the changes. Nobody else is impacting, or nobody else is changing anything on that particular branch, right? Every time you push the code to GitLab, you push your code to that feature branch, right? So the branch which gets created for your particular issue, for your particular merge request, that's called feature branch. And that your whatever changes you are making your changes once, twice, 10 times, it always get pushed to the same branch, right? So you exactly know your changes, here are the changes, and you made them. Now, once you push the code to that feature branch, GitLab executes a pipeline, right? These pipelines are created by your developers to say what exactly needs to be done. So once the changes are done, you need to build your code, you need to make some tests, those tests can be automated, you need to make some scans, what all things you need to do. Those changes, those things are created as part of the pipeline, right? As developer gets, so every time they make a commit change, so here if you can see, they push the code. As soon as the push the code, all the changes, all the steps you have built in your pipeline starts working. So your builds happen, your tests happen. Test can have the security scans, they can have the code test changes, like you are doing code test, any kind of code test, manual, automated, all those kind of things are happening on the feature branch. So the results which a developer gets, he knows those results, those issues are part of what he changed, right? Nobody else did it. I know, I'm the owner, I made these changes, and he can easily revert those changes, or he can easily fix those changes, right? Because it's like immediate feedback. They don't have to think like, okay, why this was introduced. So if they say a security vulnerability was introduced, we exactly know you make the change, and because of this a security vulnerability was introduced, right? This allows them to fix the issues right away, and main code base, which is the main master branch, is not impacted. So after a long time, you realize, you have introduced a vulnerability, rather than that, you realize it quite early on the stage when you are developing, and you can fix it then and there. Also, you can also have developers to have their reviews and approvals before the code changes, before the code is merged. This means that all the kind of results you are getting in the merge request, right? You have 10 vulnerabilities in your code, you have 2 code quality issues. All these things can also be reviewed by SMEs. So if you have security personals, if you have SMEs in your teams, they can actually look into this, and before it is merged into the master, they can give a feedback to the to the developer, like, this is not right, can you please fix this, can you please make these changes. Once this thing, this whole journey is completed, the continuous integration where you keep on developing till all the reviews, all the approvals are in place, everything is happened, and then the merge happens. This means the possibility of having issues because of something a developer does reduces dramatically, because all steps related to the changes have been tested before, have been gone through before, and what we get in the master is a reviewed and a tested code. So I said quite a lot of testing in the previous step. What are these testing? What you can do? So most of the developers or most of the product owners might already be knowing about the code test scenarios which you implement, right? So based upon your application, based upon your tool, you must already be having some type of testing in place. Other than that, there is another part of testing, which is security testing, to see the developers do not introduce any security vulnerability or a security bug in your application or in your system. We have quite a lot of security testing built in GitLab. Let's go through some of them. So SaaS scans your application for known vulnerability. So it goes through your code and see if there is any known vulnerability in your code. dependency scan scans your application dependency. So if your application is using third-party packages and all those kind of things, it will just go through it and see if those are safe or not. And if it sees something fishy, something which is not right, it will just give you a result that you might look into this and it might not be a safe version. Then there is container scanning. So if you are building containers for your application, GitLab can help you scan those containers and see if there is some vulnerability in those containers which you are building. Similarly, we have dynamic application security testing. This helps you to identify your application, how vulnerable your application is. So in SaaS, we checked for the code, right? If the code is right or not, if we have any vulnerabilities in the code. But if you want to check in the application instance, so if you're running an application and you want to scan that application for any vulnerabilities, dynamic application security testing can help you that. Then we have license scanning. So developers use quite a lot of open source licenses in their applications, in their codings, right? And there are times where an organization wants to be a little bit stricter on what licenses they can use and what they cannot. If you are on that side where you have strict requirements or restrictions on what application licenses a developer can use and what not, you can actually do it using license scan, which gives you, what kind of licenses are being used in your code. And based upon that, you can define policies to prevent developer from using a particular open source license. So you can block a particular license, which means next time a developer use that in his code, he will be blocked and he will be said, please change this particular, otherwise you cannot go forward, right? Then secret detection. This is something I think almost all the developers might have done somewhere in their whole development history. I myself have done it when I am trying to do something, trying to do some tests, and I do not want to, have the whole validation process. Just to make things quicker, sometimes we just put in the URL and password, right, to test it again and again, and to make sure we are done faster, right? But all these kind of things sometimes leads to, you just forget. You do not remember that you have something in your code, a hard-coded password. In that case, it becomes very hard to remember, and maybe this might lead in a vulnerability where somebody from outside your organization can use that. For these kind of things, we have secret detection, where it helps you to see if you might have provided some identities, some passwords, or some secrets hard-coded into your application. So instead of just trusting your gut that you did not forgot something, there is a formal process to see if some mistakes are being made because we forgot something. Happened to me, it happens. Then we have fuzz testing. This is again to, it makes issues by injecting random or malperformed inputs in an application. So if there is something random going on, or if somebody puts some random stuff into your application, how it will react, you can get all those kind of data via fuzz testing. So these are some of the scans you can implement. It's not necessary to implement everything, because it can be sometimes overwhelming for a developer to see, oh my God, so many scans, so many results, I do not understand it, right? So for organizations who are very much comfortable with security area, they have their own specification, own guidelines. It's all there. You can start using from day one. But if there are organizations who are just entering security and do not know much about it, you can take baby steps one by one, try to understand, okay, we are using container scanning. Let's try to implement container scanning first. Or we are using, we are developing code. So we can start with SaaS and then build it from there. So this is the scary stuff for the people who are not developer. I'll try to make it as easy as possible. This is all the magic. This is the place where all the magic happens, right? So developers, you might have already heard developers saying, we will write the pipelines in the YAML and all those stuff. So this is the file where you tell what all steps do you need in the pipeline? You need to build, you need to provision, you need to deploy. So here, if you see, this is the GitLab CI YAML file. So if you want to identify where your pipeline has been defined, it's always GitLab CI YAML file. Oh, sorry. And here you can see there are quite a lot of things going on. For example, here it's stages. This tells you what all stages are there in your pipeline. So I have a build stage, which will build my application. I have a test, which will test the changes. Then I have a provision, a deploy, and then a destroy, right? In this way, you can describe any stage, what you want, depending upon your pipeline, your flow. And from here, you can understand what's going on in your pipelines. Now, if you see, GitLab pipelines comprises both. They have jobs and they have stages, right? Job says what they can do. And for example, I want to do SAMs, I want to do a build and so on. And stages defines when to run that job, right? So for example, here it says job name, Terraform apply. That means this particular step will apply some Terraform. And when this will run, so I need to run it after 3 steps, or I need to run it as after 4 steps. So this stage gives you when exactly you want to run the job, right? So you can specify the job, and you can also tell in the YAML file when you need to run the job. Another part is what you need to. So if you see here, as part of the Terraform apply, we are using this Docker image. So you can give quite a lot of details on the jobs as to what exactly the job will do, when it will run, and so on. So that was a simple job. Let's look into another job. So this is again a stage. This is the job name. This is the stage. It says environments, right? So suppose you want this job to run for different environments. You can have dynamically created environments, so you can reuse the job details, right? You do not have to write it again and again. So for production, I do not need to write the same thing again, because what I'm doing in production, I'm doing in pre-production, I'm doing in development environment. So you can use links like this to make sure, you just dynamically provide your environment and the developer does not have to write it again and again, right? Also, there are possibilities of writing scripts. So if you have heard your developers, right, I need to run this before build starts, or I need to run that before something starts. So all those kind of things can be handled via this CI YAML file as well as part of the job. Then in the pipeline file, you can specify which stage you want to execute and the order you want to execute them, right? So here, if you see stages, build, test, provision, deploy, destroy. So these are the stages which will run. We will see it in the lab as well. But these also provides you which what will be the in what order you want to execute them. That means I want to first build, then I want to test, then I want to provision, and then I want to deploy. You can change this depending upon your own criteria. You can first test it. I mean, usually you build it and then you test it, but these are stages. This all list will tell you in which order your stages are running, right? You can also use variables to store value. You want to pass into the pipeline. So if you use here, if you see, there are quite a lot of variables. So you can reuse this in your pipelines instead of writing the variables again and again. And in to make sure you have a seamless variable in the pipeline. So it's not like you mistyped it in one place and in another place there is another one. So using one variable, you can just reuse it in all your jobs in all your stages. Now, this is again, you do not have to write everything from scratch. We have something called templates, right? So you can use those templates to start with. So we have almost 30 plus templates in GitLab. And if you are new to CI/CD, if you are new to GitLab CI/CD and you want to implement, you can just start working with the templates and maybe build on that, right? So that's one way of looking into it. Another way of looking at Nupur, we are quite far in our CI/CD journey. We are quite matured and we know exactly what we need to do. In that cases, there might be scenarios where different team of yours might already be reusing the same pipelines, right? So one team build looks similar to another team's build and another build. In that cases as well, it's not necessary that every team has to write the same code again and again. For those scenarios as well, you can write your own templates and ask different teams to just include them, right? This makes make sure that there is the same things are being used within the organization. It is not like one team is using something, another team is using something else, and another team is using something else, right? So if you want to follow the same standards across your organization, you can also build templates on that. And in that way, not every new team which is coming into the organization, or any team where any changes that are coming into the organization has to be done again and again, and they can be just utilized using templates propagated throughout the organization. You can use your own custom templates. So here there are, if you see, there are quite a lot of templates already present, right? For example, for Python, there is a template present for Ruby, for Swift, for .NET, for C++, and so on. As mentioned before, you can create your own templates as well, or you can use one of the one which comes out of the box with GitLab. There are over 30 templates for different programming languages. So for most of the generic programming languages in the market, you will see the templates over here. You can just click on it and start using it as is. Then there is the pipeline. So we built the whole CI pipeline by ourselves, or we use GitLab templates. Now what? After we done that, when the pipeline actually runs, so a particular developer changes the code and the pipeline is triggered, this is how you visually see the pipeline, right? And this is very interesting for the product owners, business developers to understand what exactly is going on, what all steps are being taken in my code development process. So here for this particular pipeline, my code is being built. Then the code quality is being tested, container scanning is tested, dependency scanning, license management, SaaS. There are some tests going on. There is a review environment which is being spun up. Then the DAS is doing, and then performance. So if you are not too much into the YAML file, I don't know, I cannot read YAML file, I don't understand. The pipeline, this whole UI view helps to visualize what are the steps in your pipeline and what is the structure, what is the progress of your pipelines, how do you what all things are being done as part of your developer pipeline. So you have already seen the merge request. Changes to a merge request will trigger the pipeline. So if you remember, when we were trying to understand the paths of the merge request, there was something called the pipeline, right? So every time the code is changed, a pipeline runs, right? Whenever a pipeline runs, you can see the latest pipeline over here. So here you can see the pipeline ran 1 week ago, the latest pipeline for this, and all the steps were done, right? If you want to see the history of how many pipelines ran, you can always go to the pipelines tab over here and see the history. But if you just want to understand what was the latest status of the pipelines, you can see it over here, right? You can also see, so once the pipeline run, we saw that we had quite a lot of steps in that pipeline where we were checking code quality, we were checking security scan, we were checking performances. So once the pipeline runs successfully, all the data related to that particular pipeline is populated over here. Again, for people who are not very much into pipelines, I do not want to go in the pipeline, see the logs and try to see what's happening. You can get everything from the merge request itself. here it says code quality degraded. That means whatever the developer did, the code quality because of that degraded. You can expand, you can understand what went wrong. You can see SaaS, DAS, what kind of vulnerabilities were introduced, and so on. So it gives you an overview of what your current status is related to the scans, to the test, what you have done over here. Then you also have a dashboard for the status or health of your pipeline. So if you see here, you can see what all pipelines are currently running, what all are finished, if something is failed or not, if everything is passing or not. So you can get the health of your pipelines from here as well. You can also see which are executing currently, which one passed, which one failed. So what are the current pipelines which are running uh, in your environments. You can also get an overview of that from here as well. And then there is an operation dashboard. So I ran pipelines. What pipelines do is make sure the environments, after pipelines, the environments comes into picture. I want to see how my project, GitLab projects are working, if everything is going fine or not. For that, we have something called operations dashboards, where you can see which you can choose your own project. So this is configurable. It is configured by each user. You can choose your own projects and see how the health of that particular project looks like. So because it's configurable, each project owner, product manager can actually choose his or her own projects and configure the dashboards for himself. Kubernetes supports, GitLab supports fully integration with Kubernetes. And if we say Kubernetes, that means all the clouds versions as well. So if you see EKS, AKS, GKE, we support almost all major clouds on Kubernetes. We have inbuilt container registry. So if you're using, if you're creating containers, there is a possibility to have those stored in GitLab as well. Instead of using another tool, you can create review apps for each feature branch. So if you remember in the flow, we talked about review apps, where a developer, for each change a developer makes, a review app. A review app is similar to your environment, right? So a new environment will spun up with the changes the developer had made, right? So for example, I made changes to the color of the website, right? And I just made the changes. I build it, I test it. Instead of pushing it into the master and checking it there, if you are using Kubernetes, you can use review apps. Image will be spun up and you can see the changes in that, right? An environment will be there. You can see the changes. You can say, I'm happy with that, I'm not happy with that, make the changes. So instead of waiting for it to merge into the master and then coming up with the suggestions or review comments, you can see it there and then only, and then make the changes again and again. So this is really interesting approach if you're using Kubernetes. Also, there are quite a lot of deployment strategies which are inbuilt. You can have automated or manual deployments. You can have canary deployments. You can have incremental rollouts. So you can have different deployment strategies depending upon your scenario. Also, if you're using Kubernetes, we allow you to monitor your applications so that you can get the data of how they are performing in GitLab itself. So we talked about creating YAML files. We talked about building, your pipelines. But what if I don't want to build everything? If you're using Kubernetes, there's an option, something called Auto DevOps. What Auto DevOps does is we have built a whole pipeline for the teams who are using Kubernetes, and this comes inbuilt with GitLab. So if you start using Auto DevOps, you just have to integrate your clusters with GitLab, and then you can auto build, auto deploy, auto test, and auto monitor. So if you see, these are the stages which comes out of the box with Auto DevOps, when you enable it, you can just push the changes into your repository, and Auto DevOps will automatically determine what programming languages are being used, and it will then build it, test it, and deploy. So it's kind of a easy button for the CI/CD, where you do not have to code anything. You just comes with your code, with your repository, and then you plug in Auto DevOps and you're good to go. So this finishes our slides. We will start working for the workshop. Let me open the workshop content. So you might already be on Developer Flow 3. Please feel to go back. And here there will be something called pipeline automation. Click on that, and this is our lab for pipeline automation. For this, we will be creating a GitLab CI YAML file to see how all those pipelines and how those steps work in action, right? So for this, again, let me come back to my project. So if you are, again, like me, on the merge request, using the breadcrumbs, you can just go and click on leaderboard project, and you will be navigated to the leaderboard project main page, right? Now, once it's there, let's click on the plus sign over here. So you can see main leadership project, a plus sign, and I'll just go and say a new file. Once I say a new file, I have to get this new file name. So quickly I'll tap GitLab CI.YAML, right? And if you are over here, you might already see a content, quite a lot of steps. So just copy this file content, copy it. Oh, I copied too far. Okay, let me try my hands again. Okay, this should. Okay. Okay, and I'll just copy paste this. So what this is doing is we are doing some echo step. It will just provide data. It will echo whatever we are stating here. Then it will build. Then it will test. So we have test 1, test 2, and then there is a deployment stage, right? So once you are done with copying the code, provide a commit message. Again, a good habit to make the changes, and then we'll commit the changes. So create a new YAML file, right? And I'll just commit it, right? Once you have committed it, it says CI configuration is valid. This is again something very interesting. If you are building your code or building your YAML file manually, this makes sure it validates and already tells you if your YAML configuration is invalid. It says valid. So I hope it's all going fine. The file has been successfully created. So to check, let's see if we triggered some pipeline. For that, on the left-hand side, again, if we go down on the CI/CD, we have pipelines, right? So if I click on pipelines, it will tell me the detail. Now, if you are, if you have bifurcated a screen like me, it will look something like this. But if you are using the whole screen, it will look something like this. So let me come back again. So as you can see, there is one already passed. So my pipeline already passed. So I'll just click on it. And here, so it will tell me what all stages I have run as part of my pipeline. So there is one build stage, there is one test stage, there is another test stage, and deploy. Now, these all steps have been passed. Now, if for the developers who love to understand what happened in the background, they can always click on these steps, and what all was done as part of this particular job, you can get a trace logs for that, right? This is really interesting for people who wants to understand if something fails, right? If your job failed, you can go into it and try to understand why the job fails. You can get all the details over here. I'll come back, and this is where we see, okay, our pipeline passed. I'll give a minute for everyone who already hasn't finished it or who's trying to finish it, and then we will go on the next one. Okay. I hope for everyone this step is finished. If not, if you're struggling with anything, please put your questions in Q&A, and our team will be able to help you if something is going wrong. Going on next, so this is what we did. Now we want to add another step. We want to introduce another test in our pipeline. How do we do it? Let's go on again on the left hand side. Let's go on the CI/CD. So here we have CI/CD, and then below pipelines we have editor, right? For those of you who did not follow, on the left-hand side, we have CI/CD. On the CI/CD, we have something called editor. We click on that editor, right? So we will be back to the YAML file which we just made. Now we want to add another job, test3, right? For doing that, we copy. We have to create something similar like test2, right? So I'll just copy test2 stage and the script part, right? And I'll create another step. Okay. And now I have to echo code readme. So let me see if I do not break this. Okay. And then echo says cat readme, right? So now what I have done here, and because this is test2, this will fail because I have the same name for two jobs. So I'll quickly make it test3 so that my test doesn't fail. And now what I have done is I have created another job, which is called test3. Now this job will run as part of test, right? So our stage is test. We created a job, and then what this will do is it will echo the cat, it will write the readme file for me in the log. So we will see that in a minute. Once you are done with that, please provide a commit message. It already said update GitLab YAML file. So I'm happy with the commit message, and I'll just commit my changes. So it says your changes have been successfully committed. Pipeline syntax is correct. So I'm pretty much sure I did not break anything. Let's see what did it change. Now, once I made the changes, if you can see, it already points me to the pipeline which ran because of these changes. So either you can go to the pipeline and try to see what changed, or you can just click on here as well. Let us go and check from the pipeline perspective. So again, on the left hand side, we go on the CI/CD. We have pipelines. I'll click on that pipeline. And if you can see, there is a pipeline running in progress. Again, if you are using the full screen, this might look a little bit different for you. But if I click on this particular past, now you see I have 3 tests running. Previously, it was 2. If you remember, we said that we can create a job and we can tell when it should run. For example, we created test3 and we said we want to run it as part of the test stage, right? So you can change this, you can create any job and you can tell when it should run. Now, Let's see if what we provided in the test3 job actually ran. So it says, I think I did something wrong because it says get readme MD and I did not got the details. Yeah, I think I did something wrong. Let me see if we can go and correct it somehow. Okay, let me see what I did wrong. So I'll go on the editor, right? And it says, I think I have to remove cat, right? Okay, let me try to run this again. Okay, we will wait for the pipeline to finish. It's in progress. So here, if you see live, our build process is finished. So if you see a check mark across a job, it means the job has finished. And with a timer like this, it's still in progress. So test 1, test 2, test 3 is finished. Yes, now it worked fine. So just to reiterate on what did I do wrong, let me go on the editor for you to clarify what did I do wrong. Okay, what did I do was I used echo with cat. So obviously it just said cat readme. So if you copied my steps and did it like that, you have to just write cat readme.md. So please remove echo if you did it like me. Just use cat readme.md, right? Once you do that, and if you go on the pipelines, you should be able to see the contents of the README file. So what we did over here when we said cat readme.md is we tried populating the contents of the file README over here. So if you see here, we added a new comment, if you remember, in our last lab. So you get all the details in the trace log. This is just an example to show what exactly happens in the trace log. So if something goes wrong, if something is not working fine, or what exactly happened behind when you ran a job, you can get all the details from here, right? So again, a minute for everyone to catch up if already not done, and then we can go on to the next one. If anybody have any questions or if you're not able to do any step, please put it in question and answers and our team will be able to help you. Okay. Let's go on the next step. So we have done a test tree, we have committed the changes. Now we already check the pipeline and confirm the readme.md contents are displaced, right? Now, if you remember, just a few minutes back, we discussed about auto DevOps, right? Where we do not have to write everything. You do not have to write the YAML file. You can just utilize the auto DevOps template and start building your code, or the pipeline is automatically there for you. So let's see how that works. So this can be not auto DevOps, any template, whether it's your own template or the templates which we provide. So let's see how that works. So again, on the left-hand side, you go on the CI/CD and the editor. On the editor, you will be navigated to, again, the CI YAML file. Now it says include this code. So I'll just copy this code and put it before script. So here there is an image and then there is a before script. So I'll just put it here, right? As soon as I put it here, if I click on this tree branch, right? So if you are like me and you cannot see anything else, just click on this tree branch, right? Again, as soon as you include the template, here the tree branch, right? Here it will tell what all jobs are included because we added this template, right? So as soon as you include any templates, all the jobs which comes with those templates will be populated over here. So you understand what all is being added to your pipeline when you say, I want to add a template, right? This pipeline will not run because we haven't we do not have an application which is supported. Also, we do not have a Kubernetes clusters which is attached, but post workshop you can go and play with it and try to see if you have Kubernetes application attached, how this works and what all stages are being added, right? So for now, I'll just quickly remove it. As soon as I remove it, if you see, we do not have anything. So it's just CI YAML file, right? So this is, yeah, this comes to an end. So this is how we create pipelines. We see what all steps we have and how we build our whole CI/CD structure around a project. So this comes to an end, the pipeline automation. I'll give a minute or two to finish if you're currently in between the lab. And if you have any questions, please put it in Q&A and we will be happy to answer. Okay, moving on to the next. This is the last part of transferring a project. We have created the task for ourselves. We have planned portfolio. We have seen the developers flow. We have seen how pipelines can be automated and what all data we can get out of the pipelines. This is mostly the flow which we follow in GitLab. The last part is transfer project. So a fair warning. Until and unless you are done with all the things in the lab, or if you still want to play with something, don't transfer the project. The reason behind this is we are using ultimate license capabilities for this particular project. If you transfer to your own namespace or your own project, if you transfer this project to your own namespace, you will, if you do not have ultimate license, you will lose some of these capabilities, right? So it will not react as like it is doing now. You have 48 hours. This lab will be there for 48 hours. So if you want to try something out, you can do it. Once you are done, once you are finished with everything, then you can transfer this project to your own namespace so that it does not get deleted, because 48 hours, it will get deleted from our side and you'll still have all the things which you did as part of this workshop. So again, I'll go through these steps, but do not transfer until you are done with all the things you want to do or with the lab. So for doing this, we have to follow the transfer project step. Let's go on with that. So I'll quickly open. Again, like me, you might already be there on pipeline automation, or you can just go back, click on transfer project, right? This is the last step. Again, the same warning which we just discussed, that you do not you do not transfer the project until and unless you are done, because if you do not have ultimate licenses, you will lose some capabilities. Saying that, you can take advantage of a free trial period. So if things are interesting and you want to try it for more than 48 hours, you can go on the free trial about gitlab.com free trial. You can have a free trial for 30 days, have an ultimate license, and whatever features we have today in this lab can be tested, can be just played with for 30 days as part of a free trial period. So going on to the next steps, for transferring the project, if you want a single project for later, so if you want only single project, like we only work with a single project, you can do that. Or if you want the whole group, we can skip to the next step. So for this particular step, we will be transferring only the project. If you want to transfer the whole group, we will do it in the second step. So for this, it's important that you delete all kinds of packages and registries from container registry. So if you have any container registry images in your project, it will not be transferred to your namespace. So let's see how we can find that. For that, we'll go on the right-hand side, packages and registry, right? So here you see packages and registry, right-hand side, package and registry, and here we'll go on container registry. So I'll just say leave. See here, there is no container image stored. So because we did not created any container images, we do not had any code. So this is okay, but it's just nice to check if you have any of them or not. So now we can go on. So in case you do have, you have a delete button over there, you can delete it. But if you're using the same project, it will not be there. Now you can go on settings. You can go on general. Again, right hand side, last option, settings, then go on general. In the general, you have to scroll at the bottom. In the bottom, you have something called advanced. Expand on that. And then again, go down. If you go down, there is an option transfer project, right? Using this transfer project, you have to search a new namespace. Now, if you're like me, you will already be provided with a user name, right? Again, this is your user name, right? Not your GitLab ID. So we have to use username. So for me, it's Nupur Sharma. I want to transfer my project to this particular namespace. I click on that and I click on transfer. I'll not do transfer now because I don't want to transfer my project as of now. But if you are ready, if you're done, you can go ahead and transfer the project from here, right? If you click on it, then you will be again asked to confirm it by typing the project name. If you type it and then you confirm, your project will be immediately moved to your personal namespace so that you can reference it in future. So after 48 hours, if you want to save the things and you want to go through it in the future, just transfer it to your personal namespace and that will remain saved. When I say ultimate capabilities will be lost, whatever we did today will still be there, but you will not be able to use it anymore. So all those features will not be available to use it after that, right? So this was transferring the project. You can also transfer the whole group. For that, you have to have the URL of your current group, right? So if I go on the Tanuki Racing group, if I click on that, yeah. So this is my group, right? So you can take the URL of this. So it should be GitLab terms, environments, then the session, your session ID. So I'll just put it somewhere for the reference. This will look something like this, right? So you can copy it from up and it will be like gitlab.com, GitLab Learn Labs environment. Then there will be a session, then your session ID, which look a little bit different, and a group ID. Okay. Okay, once you are done with that, you have to locate where you want to transfer the group. More often that will be your personal namespace or a different group you already created. So go ahead and create a new group or a subgroup. And so for example, I am in my personal namespace. So I'll just open gitlab.com. So here I am in my personal space, right? So here I can say groups. These are all my groups. I can go over here and create a new group. And then it says import group, right? So you can give the URL of that particular group and import it from there, right? So if you want to import the whole group, there is nothing more in the group, but if you want to import the whole group, you have to go in your namespace and then create a group from there, or a subgroup if you already have a group, and then import from an existing group, right? Any questions? So here and then connect instance. Any question, or if you are trying this step and if you're not able to do it, put it in Q&A and we will be happy to help. So this finishes our labs and our session for today. We will be here for any questions and answers if you have any. So please put your questions in Q&A and we will be happy to answer. Thanks, everyone.
And thank you, Nupur, for the very nice demonstration. Just as a reminder again, only transfer when you are ready to transfer. You still have 48 hours. Play around with the security features. I would advise to do it then, unless you're certain and finished, and then you can do it whenever you like, of course. All right. If there's no questions,